Hello everyone, this is Niteen Mohod, and here through this video we are going to learn the classification of logic families and the various parameters associated with them. So first of all we will see classification of logic family. Actually, with the development of integrated circuit technology, the gates are mostly used in the form of ICs or integrated circuits. IC logic gates are available in various types and have different logic families. Here we are going to focus on IC7400 family and the logic levels associated with. So here we have shown three levels, 0 to 0.4 volt. This is the voltage level which is treated as logic 0 in case of 7400 family, while 2.4 volts to 5 volts means onwards we have written, but it is up to 5 volts maximum in case of digital electronics. So 2.4 volts to 5 volt, that is treated as logic 1 state. The question is, what about the level which is existing between 0.4 volts to 2.4 volts? This is that level, and this is actually the transitional or uncertain state or switching state, you can say. Here we have shown the different voltage levels associated with 7400 family. So output voltage levels are identified as VOL and VOH. You can clearly see here the VOL level and VOH level. This is the 0 level and this is the maximum level, that is plus 5 volt level. And here within the transition or uncertain state, you can see the two levels associated, that is VOL and VOH. Now what is VOL? VOL is the maximum voltage at output up to which the level 0 is considered, while VOH is the minimum voltage at the output up to which or from which the level 1 is considered. Similarly, at the input side, the terms are VIL and VIH, where VIL, that is this voltage level, VIL, is the maximum input voltage, here in this case 0.8 volts, up to which the logic 0 is considered, while VIH, that is this voltage level, so 2 volt, minimum input voltage from which the logic 1 is considered. And in case of 7400 family, the respective values or levels are, for VIL it is 0.8 volts and for VIH it is 2 volts. Then logic parameters. There are different logic parameters associated with ICs or integrated circuit families. So here first parameter is fan-in. Fan-in means the number of inputs to the gate. Suppose there is a 4 input gate, then it will have a fan-in of 4. Here in this diagram, this gate, NAND gate which we are seeing here, is having 2 inputs and therefore the fan-in of this gate is 2. Then fan-out. Fan-out means the number of gates or similar gates which can be connected at the output of a gate without overloading. So here at the output of the NAND gate, there are 3 gates connected without overloading this NAND gate. We are considering this, and therefore in that case 1, 2, 3, these 3 will be the fan-out of the circuit. Fan-out is mainly depend on the current carrying capacity of the gate. In the circuit shown, the NAND gate is driving 3 similar gates, as you can see here. If the load exceeds the fan-out, means if we increase number of gates here, the original gate will be overloaded and the output voltage will drop below VOH, which will result in uncertain results. The circuit shown has fan-in of 2 inputs and similar number of similar gates it is driving, that is 1, 2 and 3, so fan-out of 3. Then propagation delay. This propagation delay time is the time required to change the output of the gate after changing the logic level at the input. This is very similar to that, means we are switching on the bulb. So after switching the button, the bulb glows. With your naked eyes you cannot identify whether it is taking some time to get glow, but it is taking some fraction of second after which it is getting glow. So that's why there is some delay exist in every input and output. So propagation delay is the time required to change the output of the gate after changing the logic level at the input. It relates to switching property of the gate or circuit, as time taken to change the output logic may be from 0 to 1 or 1 to 0. So accordingly there are two delays, that is 0 to 1 is going up and this is while going down. So thus two different propagation delays are TPLH, that is propagation delay time while going the output from low to high, or propagation delay time while going output from high to low. So these two propagation delay exists. For 7400 series, the values of TPLH, that is propagation delay time from low to high, and propagation delay time from high to low, the typical values are 22 nanoseconds and 15 nanoseconds. Propagation delay helps to decide as how fast the gate can work as a switch. What is required then? The minimum propagation delay. Then noise immunity or noise margin. This is one more parameter. So major problem faced by the gate circuitry is that the noise level at the input, due to which the logic level at the input may change, which may leads to the false output. Suppose we are applying here 0 to this NAND gate, and here also we are applying 0 to this NAND gate. So when we are applying 0 0, the output has to be 0 in case of AND gate. In case of NAND gate it will be 1. Now suppose if the noise is introduced on the input side and this 0 becomes 1 and this 0 also becomes 1, so inputs will be 1 1. So inputs will be 1 1, so therefore the output will be 0, right? So this change may occur because of the noise introduced at the input. So under such circumstance, the ability of the gate to withstand the noise, that is called, or that is measured in terms of the noise margin or noise immunity. So ability of a gate to withstand noise is measured in terms of noise immunity or noise margin, and it should be as high as possible so that the maximum noise can be accommodated. In the circuit shown here, when both the inputs of NAND gate are 1, means this is also 1 and this is also 1, the output becomes 0 because this is NAND gate. Maximum value of VOL is 0.4 volts for gate 1, while the output of this gate 1 is the input of NAND gate 2. So this output is given to NAND gate input 2, for which the VIL is 0.8 volts. Now the input voltage level is given here. Similarly, the output voltage level is also given as 0.4. So the difference between them will be the noise immunity, and therefore the combinations or circuit combinations, noise immunity will be VIL2 minus VOL1, that is equal to 0.8 minus 0.4 volts, that gives 0.4 volts. Lesser the noise immunity, sensitive will be the gate, because with very less noise the gate output will change. IC with low noise margin is not appreciable, so it is always appreciable that the noise margin or the noise immunity should be more. Last parameter is power dissipation. This is the power converted to heat and then conducted or radiated away from the device. Electronic and electric devices have limits on the current which they can handle safely, and if the current goes beyond it, that current is converted into heat and that heat should be radiated out, otherwise the circuit may burn. Dissipation is measured in watts and is given by P is equal to I square R. Now instead of I square I have written I into I and R as it is, and this combination of I R is converted into V, so I into V. Therefore we can write P is equal to V into I. So I hope the classification of logic families and different parameters associated with 7400 ICs, also the different voltage levels associated with, are clear to you. Thank you.